Good morning, guys. Today is Tuesday, June 2nd. This is going to be a really quick video on the transformation section. And a couple reminders of stuff you got to do. So within this transformation section, you're going to have 5 different types of transformations. Now, as you're going through these transformations, it's probably a really good idea to take a little bit of notes on the side about the type of transformation, what it does, and how to actually do the transformation. So what I mean by that is for like this first one, translation, when you're going through the slides, there's going to be kind of like a formula that you use. So like for translation, rotation, reflection, dilation, and stretching, there's formulas or cheat sheets per se for each one of those. And to make your life easier for that mastery test you have to do, I would highly advise taking notes on the side on what the transformation does and also what the rules are for those transformations. So you're going to have access to all of these GeoGebras I'm about to show you really quickly, but again, it'd be a really good idea to just copy those down on the side so you have them just really quick to look at each time. Also, I would highly recommend, as we start getting into more equation-based stuff, take some notes on the side, because you can't really go back and look at the slides as you're doing the mastery test, okay? So this first one is translation, and notice I have triangle ABC right here. So a translation is kind of like a slide, all right? So the orientation of the triangle is not changing, or any figure if it's a translation, meaning it's not turning, it's not rotating, it's not flipping, it's just simply moving to a different spot. So I'm translating this triangle all over this grid. I'm just clicking and dragging it. So notice it's not A, B, and C's orientation is still the same. B is still on the top, A is on the left, C is on the right. And as I move it, it's really important to notice that A, B, and C prime, so that's called prime notation where it's got the A and the apostrophe, that's showing the location of the new triangle. So A started at 1, 2, which is right here. Now I could show a little more grid if I zoom in, right? 1, 2 is right there. So, but when I move it around, notice A prime, B prime, and C prime are changing. Now, if I were to drag that directly over H, G, and F, notice that G, which is right here, has the same location as A prime, right? Just because I'm overlaying that triangle. And then if I did it here, A prime would have the same location as D. If it should snap in kind of. But that's a translation, and translations are probably the easiest type of transformation to do because you're just going to be adding or subtracting values to x and y. What I mean by that is, see how A is at 1 and A prime is at 3.23. Let's see if I can get it at a whole number. Okay, so see how A prime is at 3.3? So that means A started here and it moved to A prime. So that means for the x value, I had to add 2. So I moved over 1, 2 units. And the y value, if I go to, see how y is 2 at A, y value at A prime is 3. So that means I'm going over 2 for x and up 2 for 1. So add 2 plus 1. And that movement is the same for each shape. So if I was to draw in a segment here from A to A prime, that segment is the same length as from B to B prime and from C to C prime. We call those vectors. So that's showing the amount of movement to get from the pre-image where we started to the image, our new location. So again, that is translation, all right? Reflection, okay, revolves all around a line of reflection, meaning we are going to reflect over something. So I want you to take a look at A, B, C, and D right now. This shape right here, this quadrilateral. That shape is being reflected over this line. Okay, now notice if I move this shape, everything else is moving. That's because these figures, 1, 2, 3, are reflections of this original image right here. So what they've done for us is they've drawn in a line of reflection to show us that this figure is reflecting over this line. Now for the other two, they're not giving us lines of reflection. Okay, they're assuming that we can figure it out. So as I move this around, can you tell what we're reflecting over? Notice at this point they kind of lock and then they switch. So this one down here is actually reflecting over our x-axis, and this one right here is reflecting over our y-axis. That's why when I go across, they switch spots. Okay? Because they're always reflecting over either this line for this figure, this line for this figure, and this line for this figure here. Now, there are some rules of reflection. So this is where you definitely would want to take some notes on if I'm reflecting over the x-axis, how do they change? If I'm reflecting over the y-axis, how do they change? The other two lines that are very important are the line y equals x. So if I was to draw that line in right now, I know it passes through 1, 1, -1, -1, 0, 0, and 1, 1. So that is a very important line of reflection. And then also the line y equals -x, which would be this line here. So if you could imagine if I were to move this shape, whoops, let's go back on that. If I were to move this figure and now have it reflect over this line, it would be kind of over here, right? If I wanted to reflect over this line, it would be over here. All right, so that's going to be an activity that you have to do in one of the questions. Okay, so that's reflection. You always need a line to reflect over. And the four main ones, the four main ones, are going to be the y-axis to reflect over, the x-axis to reflect over, the line y equals x, and the line y equals -x. Those are going to be the four main rules. Okay, now if it's something that doesn't have a rule, so let's kind of back this up again. Okay, so let's say I have my line of reflection here. That gets a little more complicated. I don't think we have to cover that too much. But if I had a line that was straight horizontal or straight vertical, so let's say I had a line that went straight up and down like this, okay? Then that means that if I was reflecting over this one, this would be the line x equals 1, because it's touching the x-axis, it's not touching the y-axis. This would be a line y equals 1, because it's touching the y-axis and not. So again, y equals 1 runs horizontal, x equals 1 runs vertical. So if I wanted to reflect over x equals 1, all I got to do is count the distance from this line. So see how A would be, right now it's half a unit to the right. Let's move this over. Actually, back up. Right now, let's see how A is at 2 for the x-axis. That means it's 1 unit to the right. So that means that A prime would be 1 unit to the left. D is 1.5 units. Excuse me, 2 units. So that means that D would be 2 units to the left. So it's equidistant from the line of reflection. That's important to know. Okay, so that's reflection. Rotation. Okay, rotation. There are 3 main rotations that you have to know. 90 degrees, 180, 270. So this one's showing some other different things. So notice that as I move them all, they kind of all rotate. But there's, where's that shape that snaps over? Where are you? Okay, I see this is the slider one. So notice the slider starts at the beginning. But as I drag this slider, it's number one, it's telling me how much I'm rotating. Okay, so that's kind of cool. Let's see if I can get this guy to have some whole numbers here. So notice, guys, these are kind of manipulative, right? So A is at 2, 0, B is at 3, 2, and C is at 5, 1. Perfect. So these locations are all whole numbers. So what I want you to show you is, remember, the prime notation is after the rotation. So what I want to do is I'm going to rotate 90 degrees. And notice I'm rotating around this point right here. We call that the origin. So all of our rotations are going to focus around the origin. Now if I rotate 90 degrees, so I'm going to drag this all the way to 90. Notice the relationship here. A is at 2, 0, A prime is at 0, 2. The numbers are exactly the same, but they switched locations. B and B prime, 3, 2, negative 2, 3. Same integer values, switching locations, but one became negative. C and C prime, 5 and 1, negative 1, 5. Same integer values, switching locations, but again, one became negative. Now, the way you'll know what to do is by the rules. So that is something you, again, like I said, take notes on what the rules are. Because if I go to 180, notice same numerical value, same integer values, different signs. 2, 0, negative 2. 3, 2, negative 3, negative 2. 5, 1, negative 5, negative 1. And then finally, if I go to 270 on this slider, again, same integer values, but places are switching and things are becoming negative. The way you'll know what to apply is by looking at the rule in the slides. Okay, so that's rotation. And again, we'll always be rotating around the origin. Next one is dilation. Now, dilation is pretty simple because it's all going to be multiplication. We always dilate from the origin. And so n equals 2, that's called the scale factor. How much bigger am I making the figure? So notice if I drag this and I go to 2, that means that this new image is double the size of the pre-image. Notice it's moving to the right because when we dilate by a scale factor greater than 1, we're moving away from that origin. Okay? It's because if I go, notice I go to 1, that means I'm not doing any dilation, but if I go to 1/2, it moves to the left because that scale factor is less than 1. Dilation is one of the easier ones because all you're going to be doing is multiplying each x and y value by the same amount. So notice my dilation is 3, my scale factor is 3 here. All I did was take the x and the y, multiply it by 3. That's how I got A prime. Take the x and the y, multiply each of those by 3, 9 and 6. 4 and 1, multiply by 3, 12 and 3. So dilation is a pretty simple one. Okay, the rule is you only just multiply x and y by the scale factor. Now the one that can be kind of tricky is stretches. So a stretch, if I'm stretching horizontally, watch what happens as I drag the slider. Only the x values are changing. Notice that the figure is not getting any taller, it's just getting wider. If I drag this vertical stretch, it moves up, but it does not move horizontally. Very similar to dilation in that you're going to be multiplying, but if it's a horizontal stretch, you're only applying to the x's. If it's a vertical stretch, you're only applying to the y's. All right? So guys, that's the different types of transformations you're going to work with today. Remember, the tutorials are practice. Those do not count technically as part of the grade. The mastery test is what reflects in your grade as far as the unit modules, that 50% of your grade. Okay, so, and again, you can do the mastery test 5 times, okay? But in order to do the mastery test again, you have to go through the tutorial slides. That's why I always say it's better to take your time the first time. It's going to save you time in the long run by taking your time the first time around than if you rush through it and try to guess in the mastery test, because you're kind of hurting yourself on the back end. Okay? Hopefully this helps you guys out.